Suppose we're given the function f of x equals 5 over 5 minus x, and then we're going to square the whole thing. So let's think about what this will look like. I see that it's squared, so think about, does that tell you something about if it's positive or negative? Is it always above or always below the x-axis? And are there any special values where something funny is going to happen? So I see if I plug in x equals 5, I'm going to have a 0 in the denominator here. So that'll cause the function to approach very high values. Approach infinity at that location, x equals 5. So let's take a look at that. That is indeed what we see. It looks like a Mount Doom sketch from Mordor here, moving up towards infinity at the location x equals 5. So we have a vertical asymptote there. So we can use the fact that the only part with an x in it here is in the denominator to separate this into two parts. So I see that really this is 5 squared over 5 minus x squared. And then we can use our love of negative exponents to rewrite this to make it easier to apply the chain rule. So first, let's see, 5 squared is just 25, so we have a constant sitting out front, and this is 5 minus x to the negative 2, negative because it is in the denominator of this quantity. Now, why do we prefer to write things with negative exponents like this? Well, it is easier to apply this chain rule when we can just use the power rule, one of the simplest derivative rules. So let's rewrite that, as we've been doing, as an outer function and an inner function, and then we'll apply the chain rule. So f prime of x will be 25 is along for the ride. Negative 2 comes down, so we have a times negative 2. And then our parentheses stay here. We have a lower the power by 1, so this comes down to the minus 3. Let's make a little more space for ourselves. Remember that the inside is going to stay the same. But what do we still need to do? Think about that. That's right, we need to multiply by the derivative of the inside, which is what? It is derivative of 5 is 0, because that's a constant, and derivative of negative x is negative 1. So that is our derivative. Let's resolve these minus minuses. So if I have a minus 1 times a minus 2, that's a positive 2. So here we're going to have 50 times 5 minus x to the negative 3. So that will be 50 over 5 minus x. The quantity cubed is another way of writing that. As usual, let's check that to make sure that it makes sense with our visualized function. I see that I want a function that has slope that goes from 0 to extremely positive, suddenly becomes extremely negative, and then comes back down to 0. Let's enter that function that we just found. We have 50 times the quantity 5 minus x to the negative 3. So we've got that function in black there. It's our original function. And the black function, the derivative, is indeed, let's do a dotted line so we can see through that function. Indeed, it starts at 0, it's becoming very positive, just like the slope of the red function, and then it comes to a extremely negative value and back over here. So that is how we take the derivative of a quantity like that.